Yeah, so I think there's really two major impacts. The first one is kind of the obvious one, which is productivity and the ability to produce quality output faster. I would say, I would estimate my own productivity probably, on net is at least double, maybe triple using the tools. Now, that's not universally spread. Obviously, there are some things where it dramatically improves productivity and other things where it doesn't. And frankly, a handful of things where it slows you down. And so for certain small things that if I just needed to change a value in the code, that for sure would be much easier to just manually go in and do rather than trying to interact with the LLM and have it do that. And sometimes if there's something that I know exactly what it is that I need to do and how to do it, it's much easier to just go in and do it. So, but by and large, the impact on productivity is substantial. It helps a little with the thought process where the real productivity gain comes from is the actual mechanics of typing in code. The reality is that as an engineer, prior to the existence of LLM tools, obviously there is a thought element of anything that you're going to do, but then there is a mechanical element of it where you have to just punch in the code. And that used to be a substantial chunk of time. I frequently will have conversations with clients and I explain to them, nothing about what you're describing that you want is hard per se, but it just takes time to go in and write code. And now that piece of it has been dramatically reduced in the amount of time that it takes to write code, just the mechanics of writing code. The other place where I feel like it has really significantly impacted is sort of those tangential elements. But what I was mentioning, when you have additional tools that you can use now for troubleshooting, when you have additional tools that you can use to expose information, and even the kind of the analysis elements of it, because that assists with the thinking part. It's not the impact there, I don't think is as significant because obviously the mechanical part, it could easily reduce that by 95%. But the thinking part, having the tools where they can run some analysis and then provide information that then gets fed into that thought process, and then you ask the next question and it analyzes the log or it looks at the code for whatever it was that that you're doing, and it can just do all of that quicker and then give you the information that you need. So rather than bouncing around through files and trying to find references to a variable or whatever it is and figure out how it's being used, the tools will analyze it, they can summarize it. Obviously, if there's still questions or if you feel like you don't have everything that you need from that, you can still go into it and look at it yourself. Nothing is preventing that. But the fact that you can get those additional layers, you can get that high speed analysis where it will page through everything. And the other thing that I found is it's helpful because it doesn't miss things that people would miss. So sometimes you'll go and you'll be looking to update something and it's a code base that you've been working on for a while. And so you update, you go in and you change whatever it is that you're looking to change, but maybe you forgot or didn't realize that there was another reference somewhere else that is not used very often, it's code that doesn't get hit very often. It's kind of an edge case. But if that didn't get updated too, then obviously it's not going to work right. Another place where I have found it is sometimes you have code bases where multiple engineers over many years often have worked on it. And so what you'll have is you'll have a particular output that it is doing or a particular process or something like that. But at different points in time, different engineers may have referenced it differently. They may have used a different variable for it. Sometimes somebody coming new into a project might not realize that there was a function that did what they wanted or almost what they wanted already existing. So they wrote their own thing. And so toggling a particular pin in the GPIO, a particular GPIO pin, you might think, okay, that's what we're doing to control an LED, say. And so you look at the LED control code and you update that to do something else. But what you don't realize is that some other engineer 2.5 or 3 years ago when that pin was connected to something else or did something else, wrote a different function that also interfaces with it. And so those types of things would just sort of get lost in code sometimes. And the tools are very good at identifying that. And so if I was to go in and say, okay, I want to update this LED control pin so that it will now point to this other thing. And then oftentimes the tools will come back and say, okay, that is here, but also in this other location in code, that particular pin is also being referenced on something else. And so that I have found it also dramatically improves the quality of what is getting produced as well, because you have fewer things that slip through the cracks. You are presented with more information so that you're able to make better decisions. And so the ultimate output is significantly improved with that combination. It's really that combination of a human programmer and the LLM tools that is the sweet spot. The vibe coding, it can work for some things and certainly some high level things. I think it will be some time before that's possible for embedded systems, just because of all of the differences and the hardware constraints and other things like that. But the combination of a knowledgeable embedded engineer using those LLM tools, from what I have seen in my own productivity, is an easy 2 to 3x improvement, and in some cases more than that.